welcome to your Unit 9 study guide. All right, these first few, we're just going to plot these points in polar coordinates on our polar grid. I kind of don't like this grid too much. I think there's too many lines on it. Each one of these is a 12th. Like this would be pi over 12. So this would be pi over 6, and then pi over 4, and then pi over 3. And then what would that be? 5/12. So you can kind of ignore the first one and the last one as it goes around. But what you're going to do is rotate that amount, and then this is the radius. So go that far for the radius. So pi over 4 would be right here, and we're going to count out 1, 2, 3. And you do have to label the point for me so that I know, which one it is that you're plotting. All right, so here we're going to go 3 pi over 2. So that's going to be down here, except the point's not going to be down here. It's going to be up here because it was -7. So we're going like the opposite direction. So I'm going to count up 7. And here's our -7, 3 pi over 2. And then here we're going to go 4 pi over 3. That's going to put us down here in the third quadrant. 3 pi over 3 would be 1 whole pi. That would put us right here. So 4/3 is going to put us along this line. But the point won't be down here. It is going to be on the other side because it was a -4. So 1, 2, 3, 4. That's going to put us right here. And that is our -4 pi over 3. So you just rotate that amount and then go that far for the radius. If it's negative, it goes the opposite direction. All right, for number 2, just as a heads up, this is going to be like really repetitive. I kind of put this on here though, just to like give you some easy questions. You're going to end up writing the same thing kind of over and over again here. So we're going to use r equals 1 - 3 sine theta, write an equation for y. So y is going to be r times sine of theta. So it's just this times sine of theta. Then x is going to be r cosine of theta. So it's just this and then times cosine of theta. So dy d theta, we're going to do the derivative of this. It's going to be a product rule. So the first thing times derivative of the second, derivative of sine gives you cosine, plus the second times derivative of the first. So that would be, and the one's constants, that's going to go away. That would be -3 cosine of theta. Dx d theta, we're going to do the exact same thing for this statement. So again, a product rule. So it's going to be first times derivative of the second. That would be -sine plus the second times derivative of the first. Again, -3 cosine theta. And here's where this is going to get a little bit repetitive. Again, I just threw an extra question on here so you could get another point for it. Dy dx, it's going to be all of this over all of this. So, just recopy it and don't do a copy error. I should have paused the video while I was doing it. Oh, well, you guys can fast forward if you don't want to watch me writing it. All right, so it's dy d theta over dx d theta. So all of this over all of this. All right, the tangent line when theta equals 0. So for a tangent line, we're going to need a point and a slope. So for the point, we're going to use our x and y statements right here. So we're going to plug in 0 for theta for x. Cosine of 0 would be 1. So basically ignore that. It would just be times 1. Sine of 0 is 0. So you get 1 minus 0, which would be 1. So our x value is 1. Plugging in 0 for y. So sine of 0 is 0. That's going to make this whole thing 0. So 1, 0. And slope is going to come from our derivative dy dx. We're going to plug in 0 for all of this. So sine of 0 would be 0. Cosine of 0 is 1. That whole thing is going to go to 1. Plus, this will all go to 0. Sine of 0 is 0. So that will all be nothing. Same thing for this statement. This part right here is going to cause it to all go to 0. Cosine of 0 is 1. So both of these will be 1 times -3 will be -3. So this will give us -1/3. And so we're going to use that point and that slope, just put it together into your equation, and that is your answer.